Alright, so far we've done the product rule, the quotient rule, now we have the chain rule. And this rule is extremely important, highly used, really important. And at first glance, it's kind of confusing. So hang in there with me. It'll make sense, but it is everywhere in calculus. This rule is enormously important. Here we go. If you have a composite function, a function inside of a function, and you're taking the derivative of it, what you're going to do is you're going to take the derivative of the outside, the f, see right there, leave the inside, the g, and then derive the inside, multiply it by the previous. Okay, let me say it one more time. You see how the outside function's f. You derive it, leave the inside, whatever it is, and then you multiply that result by the derivative of the inside. Okay, that might not make any sense. Let me show you how it works with this practical problem. All right, this is a composite function. It's f of g of x. There's something inside of something else. So watch this. I'm going to rewrite it, make it a little bit easier to see maybe. I have 3x squared minus x, and I have a 1/2 power. The square root is a 1/2 power. This makes it easier to see and easier to take the derivative of. All right. Do you see how the outside, the f, the outside of it is the square root of x, which is the 1/2 power. That's the outside. And the inside is your g. Okay. So the outside is the square root of x. The inside is 3x squared minus x. So what we do to take the derivative of it, if I want the derivative of f, I take the derivative of the outside. So the outside, the derivative of 1/2, leave this. So 1/2 basically something. Well, what that's going to be is 1/2. Okay, just be careful. You have 1/2, you take it out front. You just leave this, and you subtract 1. What's 1/2 minus 1? 1/2 minus 1 is negative 1/2. All right. Now, I leave the inside. So I'm going to just leave the 3x squared. So see there in green, I derived the outside. I took the 1/2 out front, dropped the power by 1, and just left the inside. But what am I now going to do? I'm going to derive the inside. So this inside piece right here, this piece right here, I'm going to derive it, take the derivative of it, and multiply by it. So what's the derivative of this inside? I'll take the 2 up front, that becomes 6x, and the derivative of negative x is negative 1. That might have threw you for a loop, what I just did. That is the chain rule. You derive the outside f function, so I derived 1/2, something to the 1/2 power, so I take the 1/2 out front, drop the power by 1 in green, left the inside. Then I derive the inside, derive g, multiply by it. So when I derive this, I put it right there. That is the chain rule in full form. Then we got to simplify it. Okay, so to simplify this, let's see what we get here. What does a negative power do? What doesn't it drop to the bottom? Okay, I want the 2 be on the bottom. So if you think of a fraction here, the 2 is going to be on the bottom. All right, is this 6x minus 1? That stays on top. And the 1/2 power goes to the bottom. And isn't a 1/2 power a square root? Okay. Could I leave that as a 1/2 power? Could I also make it a square root? Depends if you want the square root or not. But that right there is a simplified version. Remember, you want to put your negative powers back into non-negative powers. Okay, you don't want answers with negative powers, basically. It's usually not common to have a negative power answer. Now, that could be a square root there. There's no simplification I can do here. Some of you think, oh, I can cancel 6 and 2. Yes, no, you can't. Be careful. That doesn't reduce because it's 1, the minus 1 there, so you can't cancel that off. You can't bring the 2 inside. It's not part of it. That is basically your answer. So once you do the chain rule, try to simplify it down. All right, let's try the chain rule on this trig function. Now, I call these double chains. This is a little trippy what's going to happen here on this problem. It's a little weird. So watch this. I'm going to take the derivative of g. I'm going to rewrite this as secant 4x squared, all right, all to the third power. All right. Now, because I don't like that cube there, it's easier to see the cube on the outside, so you can see the outer functions and stuff like that. So here we go. We're going to take the derivative of g. All right, it's a little weird at first glance. What is the outer function? Can you see the outer function is the 3 blank? So I'm going to take the 3, bring it out front, leave the inside, drop the power by 1. So I did 3 blank squared. Okay, what's on the inside? Right there. So that's just going to be, okay, secant 4x squared. Yay! Looks like I'm done. No. Derive the outside in red, left the inside in blue. Now I got to derive the blue. All right, ready for this? Take the derivative of the blue. Well, I have another product rule. No, sorry, another chain rule. I just did a chain rule. I have another chain rule inside. Oh no! Okay, here we go. So what I got to do is I got to derive the outside because I have a secant with something different inside. So I got to derive the outside now. Ready for this? The outside is secant. The derivative of secant is secant tangent. Okay. Now, so the derivative of secant is secant tangent, and we leave the inside. So we're going to leave the inside of 4x squared. 4x squared. So I left the inside. So the derivative of secant, secant tangent, but I left the inside. I now have to derive the inside. So what's inside of these? Don't think of doing both, but what's inside of the function? It is 4x squared. So what's the derivative of 4x squared? Bring the 2 out front. 8x. All right, I might have just lost you. So let's redo this. You have to do that. You have to kind of think it through. That's what's great about videos. You could wait, fast forward, rewind. Wait, what just happened? You might want to rewind right now and see what the heck just happened. I'm gonna explain it too. Okay, take the 3 out front, drop the power by 1, leave the inside. Now, I am now going to be taking the derivative of the inside. The derivative inside, well, that's another chain rule by itself. So what we got here is secant, so I derive the outside of the secant, the inside is 4x squared. So the derivative of secant is secant tangent in green. Leave the inside, leave the 4x squared. All right. Now I got to derive the inside, which is the derivative of 4x squared, 8x. Do you see how I did the chain twice? It's kind of trippy. And trigs are the ones that usually have this double chain if they can. If they do. So. All right, but that's the answer. Now let's just do a little simplification. All right, g prime x, the derivative of g. All right, let's multiply all this together. Well, let's see. Can we combine these two guys right here? Yeah, 3 times 8 is 24x. Okay. Well, can't we multiply secant 4x squared and secant 4x squared? Now, isn't this a squared? So don't you have 2 secant 4x squareds and then 1 more? So wouldn't that simply be secant cubed 4x squared? You see how you have a squared and another secant? Both are the same inside. And then we have this tangent. 4x squared. Okay. If you want to, you could put these in parentheses. If that helps you separate everything better. Alright. And that would be your answer. Nice and pretty. Okay, I say it's pretty. You might not think so. Nice and simple. Now you could technically make secant into all. You could probably do some sort of configuration to simplify this, but we're not going to go there. You can simplify trigs like there's no tomorrow. You could just keep changing like secant into 1 over cosine. Tangent, you can make it sine over cosine. I mean, there's just so many things. We're not going to go any farther, but that would be a nice simplification. So, chain rule. Derive the outside. All right. leave the inside, derive the inside. That's the process. And on this kind of problem, you got to do it twice. Now, not all trigs are double derivatives. You just got to think, okay, when I take the derivative of this, do I have to do a chain again? Most of the time, no. I just showed you kind of a really trippy one. For instance, here, I took the derivative of the outside, that's the green, left the inside, and derived the inside. Simplified it, I'm done. The chain rule is very important. And here's what's going to get annoying. You're going to do the chain rule and have products and quotients involved with it. So you have to do products, quotients, and chains all mixed up, all together. It's going to take some time to get used to. The chain rules in everything. There's all these other properties you're going to learn in the future, and the chain rule is like the bread and butter in all of it. So get good with the chain rule. And it might need to review this video if you need a little bit more help. It can be a little trippy. Good luck.